Hello, everyone. Welcome to the special episode of Manufacturing Hub this Wednesday afternoon. Today, Dave and I will be talking about AI, artificial intelligence, in various form as it relates to manufacturing. So we have prepared, I guess, a series of different labels that we believe are important or of interest to a manufacturer, I would say, of any size. And so the goal today is really to brainstorm, I want to say whiteboard, a couple of different ideas when it comes to AI and how it applies to certain and specific areas in manufacturing, but also to discuss some of the challenges on what it would take to deploy them, what kind of opportunities there are, but also what kind of challenges and maybe problems they could solve for different manufacturers. So we're going to, I guess, Dave, before we dive into the board, any comments or, I guess, notes before we get into the conversation?
Yeah, everyone's super happy to be back live in person with you guys. It's been a little bit. We've had a bunch of fantastic conversations come out that we did previously in the year. It's been a little bit since we've been in front of you guys. A couple of notes. We weren't necessarily intending to have a split theme for the month of June, but I'm pretty sure that we have successfully managed to despite our best efforts, have a split theme. So for the first couple of months, or for the first couple of weeks of June, we're going to talk about AI. So Vlad and I will be talking about AI in manufacturing this week, and then our guest Billy Albritton is going to rejoin us to go talk about AI in manufacturing. And then later this month, we're going to have a short robotics theme to go ahead and dive into a couple of specific applications on the robotic side. So super excited to have that. And then I will say for our long-term listeners, just as a note, we've got a bunch of automate content coming out.
Mhm.
Vlad has been trying those AI tools that we're going to talk about on some of that content. Good news, you won't be seeing any of it because those applications are absolutely terrible in many cases. Despite Vlad's best effort in order to go leverage some of those tools, they are not quite production ready. So having said that, really excited to go have everyone on. Really happy to go get back into this whiteboarding. For our long-term listeners, this is like the fifth or sixth time we're using basically this infinite canvas of a whiteboard. And so happy to go ahead. And we're going to do the most difficult things that anyone can possibly do, which is literally go through the process of talking and typing while we talk about slightly different technical things and going and showcasing it to everyone here on the internet. So
Good.
having said that, I guess let me introduce what we've put together or what we've started to put together here, and then Vlad, I'm going to go let you pick a specific application. So,
Yep.
down the left side, we've got some high level AI style applications. We've got five of them here. It's just basically an overview and example of five different things that we could 100% talk about. And then down the middle and right hand side, we've got under the title of what it says AI in manufacturing. We've got some what we're defining pre-operations. So all of your tools and CAD and in theory your systems, so your Studio 5000 and your TIA portals and everything like that, along with simulation and those other tools. We've got operations, which is the physical operations portion of the conversation. Everything from your maintenance to your batching processes to your quality to your personnel scheduling. We've got equipment and software. So we do need physical things to run in manufacturing. It would probably be easier if we didn't need physical things to run in manufacturing, Vlad, but alas, we do need physical things to go run in manufacturing. So you've got your machines, you've got your lines, you've got your physical PLC, HMI, SCADA, MES, ERP, etc., other systems. And then as Vlad is building here, we've got our post operations. So right, so everything that happens beyond beyond we've gone and produced. I do want to make a note, and Vlad and I have discussed it probably briefly in the past and before this show. There are probably an infinite number of applications that you could go use for different tools, be it your accounts payable, be it your
Hmm.
accounts receivable, be it your raw materials ordering, supply chain, everything along those lines. Vlad had joked of what would happen if someone was going to go use AI for 100% of your HR applications. What sort of people would you get to show up to the shop? We don't know, and that is not something that we are going to go dig into. We're going to do our very best to focus on some of those very specific to manufacturing levels of artificial intelligence. Having said that, with that introduction, Vlad has built a post-operation side, which talks about mostly optimization. And we will go continue to build this out as we continue the conversation. Having said that, Vlad, do you want to go talk about perhaps the first high-level item that you're interested in discussing, and then we can go down the route of building that out, maybe talking about some things that we know and have seen.
Yeah, so I guess let me set the stage a little further, Dave, right? So I think you made some really good points. So, number one, again, we're focused here on sort of the operation side of manufacturing, right? We're not talking about finance, HR, and maybe some of those other tangential applications that could certainly benefit from AI, but definitely something to be paying attention to outside of the conversation today. Number two, yes, as you said, I think the high level items, the intent here was again to mention some of the conversations that you will or are likely to hear at different talk shows, different events. I think predictive maintenance, machine vision, production optimizations have all been topics that we've heard about. um, the last comment I will also make is that AI, for those that are maybe a little bit unfamiliar, it almost feels like there's different buckets, right? And so the different buckets in my mind are sort of the traditional, or I want to say numerical models, and that applies, and we'll obviously discuss those nuances for the specific application, but numerical models where you're trying to figure out maybe better statistical approaches on how to solve a problem. Then there's the current, I want to say, wave of large language models, or LLMs, where you're basically, if you're using a personal chatbot like ChatGPT, you're trying to apply something similar to your process. And I would say the third wave of the currently, I want to say, utilized AI or discussed AI would be agents, right? So those are kind of the three buckets I would say that you should be paying attention to. And as they've mentioned, as we dive into some of these use cases, we will make note what makes sense and doesn't make sense, right? And the goal here is to really start breaking down, because predictive maintenance could mean a lot of different things depending on the size of the organization, the team, the person actually using AI. So we wanted to really dive a little bit deeper than just that higher level label and discuss where the applications could be. So let's start with, pre-operations. So for me, I define that as how is AI impacting the shop floor before machinery actually, starts producing a product, right? So here we have design tools or CAD drawings, we have selection tools. So there's a couple of companies, including some of which we talked to, that allow you now to create a bill of materials, or even to choose, what kind of cell do you want based on different prompts. There's solution evaluation, there's a lot of like simulation type of AI. And again, whether that's, you know augmented virtual reality or virtual reality paired with AI is a question mark. And then there's, system programming. So before you, like I said, deploy the machine, you can obviously use artificial intelligence to do some of those things. So let's start with, design tools, maybe in CAD. So I guess I'll start off on this use case, since that's the one I picked. So a lot of manufacturers currently design CAD drawings, right? So I'm gonna keep it within the context of, let's say, electrical design. So not talking about, mechanical components, because that would be quite a bit different. But when it comes to electrical systems, you're basically having somebody sit down and essentially line by line, with I would say, with perhaps some previous templates, create the drawing for every single panel, right? And that applies to electrical, AutoCAD electrical, that applies to ePlan, that applies to a lot of different tools. Where I think would be, I guess, an interesting idea is, I would assume that there's a lot of electrical drawings floating on the web. I think it would be interesting to give the AI a set of, I guess, a set of parts, and have it create the bill of materials for us, and then validate the standards, right? And those could be almost two different ideas. First, create the drawing, and second, validate the drawing against a specific electrical code, or maybe design code in a specific area. Dave, what are your thoughts on that side?
I think it's interesting. I think it's an interesting concept when it comes to that. I feel like as much as I would love it to be easy enough of of giving it the NEC code, or whichever code you're using or series of codes you're using, and asking it to go ahead and build that. I think it would take a significant amount of work in order to go feed that information to a bunch of, hey, this is what our typical bill of materials looks like in the past. Having
Hmm.
said that, and as I've talked about on the show over and over again, that is not really the type of work that I do. The relatively insignificant amount of time that I am going and building a bill of materials, um, that would absolutely be fantastic, right? So an AI bot of some sort could almost certainly do it better than I could, and could probably do it as well as I could, and could do it significantly faster than I could. Having said that, I think it would be really interesting to go compare what those looks like comparative to people who are doing that all day every day, and then specifically compared to, can it go pull from our normal baseline of materials, or for example, if we are we're over in Europe, we're a Siemens house, right? We do the majority of the things that we do in Siemens. Is it pulling things that are on the Rockwell side? Is it pulling things more on the North American side? What is it able to use in order to go down that process? So I think it will be interesting to see what that process looks like. I feel like in theory, that should be a fairly easy application, right? Yeah, I
Hmm.
think in theory, that'll be a fairly easy application. I think in reality, when it comes to, we're not just designing to code, we're designing against our specifications. There are lots of, I would say, human intents that we have when we go write SOPs, when we go write standards internal, when we go write standards external, that may or may not be it may or may not be able to be ingested by the models, and they may or may not come up with the same intents that we have. So I think it'll be interesting. Again, I don't do enough work in that section or in that part of the world to be able to go ahead and do that. I would imagine that the majority of like OEMs are going to have a large part of how do I want to say? I would imagine the majority of OEMs are going to have a large part of like the normal 90, 80, 90, 99% of these are the things that we use every single time. Maybe we change a 15 amp breaker to a 20 amp breaker. Maybe we change this controller to a slightly larger controller, something along those lines. But I would imagine that the majority of those groups already have items in place in order to in order to be successful with the majority of those applications.
Gotcha. So by the way, I guess like the intent of this conversation is also, if you're listening to this, to maybe provide us with some feedback or knowledge if you are working within that specific, I want to say, application, and tell us, hey, maybe this is interesting or maybe this is off mark, so that we could, again, understand a little bit better where some of the pitfalls might be. To me, it seems like, you're bringing up really good points.
Mhm.
But I think the important thing to recognize is that there is, at least in my mind, definitely an opportunity to improve the space based on what I'm currently seeing, right? So I'll give
Mhm.
you examples. I also don't necessarily lay out my own drawings, but I've worked with groups that need to create them for every single machine build. And ultimately, a lot of time is spent, number one, on the knowledge of the NEC, right? So that needs to
Mhm.
be applied based on the region or the state that you're in. And usually, as far as I know, and I could be wrong on this, but different states would apply it at different time periods.
Mhm.
So basically, across the entire US, you probably have like four or five different versions of the NEC that is applicable to the machines that you're designing, right? So basically, someone just needs to be very knowledgeable based on thousands. I don't know if it's thousands of pages. I think it's hundreds, maybe, of pages, and make sure everything is good, and to be able to generate something that makes sense. But I will add a few points to the model, and basically, like I said, the goal is maybe we'll share this at the end, and then others can add to it as they see fit. So we talked a little bit about bill of material generation selection tools, right? So what do I refer to this by is, so let me give you an example, right? So if I'm a production engineer and I'm working on a specific line, I'm looking to perhaps, make something bigger, right? So let's say I have a servo drive that failed multiple times. I'm trying to figure out, maybe I need to upsize, or maybe once it fails I need to get something smaller just because we can save a little bit of cost. The idea here is that you could generate a bill of materials based on, a description of the problem from the end user, right? And this could be as small as, hey, help me choose a servo drive because I have this one that's obsolete or that has failed. And it could be as complex as, hey, we're building a new machine that has, I don't know, five mechanical, I want to say, drives or arms. Help me, create a bill of materials of all these parts that we need, which could include, different vendors. It could include parts as, as complex as the drives, but as simple as, flanges that we need to mount the motors. So I think the idea here is to use AI to generate these bill of materials almost automatically for entire projects.
Yeah, I will say we've got Buddy in the comments saying that he sees this type of application. And I would certainly like to know how, especially the design tools and the DOM tools, compare using that as like an AI application comparative to a human. So I think that's absolutely really interesting. We actually also
Mhm.
had another comment from Sammer talking about virtual PLC with AI coding assistant. Do we think that this will work in the future? And I know we're jumping slightly ahead down in the pre-operation side, but I will say, Vlad and I have had a bunch of conversations. Well, I've had a bunch of conversations, and Vlad has had been there with me for some of those conversations when it comes to the initial industrial co-pilot on the engineering side, and we'll call it an AI coding assistant. That's probably the correct term. Was the initial Siemens, Microsoft, Scheffler, which is the German organization, the German OEM who is using that. And I've seen a couple of case studies that have come out, and I've had a couple of conversations where they were able to generate the majority of the code. I don't know how far they've gotten beyond the majority of the code, but we certainly see the majority of the code coming out of that as a co-pilot, as an interesting move. And for them, it was how can we do the majority of the work and have a human go do the rest of the work because we're struggling to go get the humans who have the baseline knowledge in order to go build the majority of the code. So I think that that is an interesting application. As Vlad and I have talked about, again, neither of us are OEMs. And because neither of us are OEMs, we're not generating hundreds of thousands of lines of PLC code or pulling off of base templates dozens or hundreds or thousands of times over the course of every year. So I guess I will go summarize my thoughts on Sammer's comment. And we'll let Vlad go have a whack at it as well. But on my side, I think that we will continue to see more and more AI coding assistance inclusive of PLCs. I think depending upon the specific language that we're talking about for PLC programming, some of it might be easier, some of it might be slightly more difficult. But I do anticipate that we are going to go see more and more of that as we try to automate the very basic, most time consuming, less human necessary portions of coding, inclusive on the PLC or inclusive of PLCs. Vlad?
Yeah, so look, on my side, I think that there's a lot of conversations to be had before we have something tangible. I think, first of all, I guess based on that question, there's two different things, right? Virtual PLCs and copilots slash AI to program PLCs. I think that virtual PLCs are nothing other than server ran or server hosted software, right? So at the end of the day, I guess PLCs were created out of the need of making a more robust box than a computer at the time. So for me now with the current IT tools, I think it's more than fine to run quote unquote virtual PLCs. But I think time will tell. I think that ultimately we will see a lot of fairly simple use cases. But when it comes to communicating, I think PLCs evolved beyond that, right? Beyond what I'm saying, and now have very robust backplanes, for example. So I think when you start introducing components like um, high speed motion or safety, it's going to be a question as to how good that safety or that motion application is going to be via a virtual PLC versus a traditional piece of hardware, right? Um, when it comes to AI and copilots, so Dave mentioned number one, I think it depends what you're programming in. I think ladder logic is going to take a little bit of time naturally, right? I think it's no surprise to anyone that structured text is a lot easier and more accessible for AI because it can parse the text. I think for that reason, it will be a lot more difficult to, I want to say, sell, but also validate the projects that you create using copilots or AI into the current manufacturing organizations, right? So it's definitely, I think, an opportunity, but like I said, difficult to implement in the real world. I would say, and I'm actually using a couple of different tools on the software side to create code and then to run different applications. AI is absolutely amazing. I have shown some of the tools, I guess, that I've built in 10 to 20 minutes using nothing but prompts in Python, right? So a little bit different than PLC code. And I had engineers with 20 plus years of experience on Python tell me that would take 2 weeks for us to implement. So I think it's definitely going to change a lot on how we do things. But I think on the manufacturing side, just like everything else, it will take a little bit more time than we would like. So that's the short answer. But I think make no mistake, it's definitely going to change how things are developed, how things are changed. I think, and this is a comment that I've heard from some of my colleagues in the software space, is that good engineers are only going to get really good with AI, and entry level or early engineers who are unable to validate the code that it's generating are going to get worse with AI. So that's kind of where I would leave that. Um,
Right? I agree with that statement. I think that makes only more larger issues for us as an industry or as a series of industries of how do we create more junior engineers in the future if we just had AI doing a majority of that work. But that is not this conversation. We do have an
yes.
update for everyone when we're talking about the design tools and the BOM generation from Buddy. He says it takes a human to sign off on the drawings or a PE professional engineer for design drawings. They ingest the PNIDs, the single line drawings, check them for changes, or provide other information to the engineers. They can automate the repetitive parts, such as BOMs being manually checked against a spreadsheet right now. And it's a very inefficient process to do that. So it's not very, to me, it's not surprising. I think it's really good information. I'm happy to know how other people are using it. And I think very similar to the coding portions of the conversation, I think it's very much we're going through and reducing some of those extremely long super manual tasks that we have been trying to get rid of for, I don't know, as long as we have had them. Because at the end of the day, I don't think anyone wants to go spend their entire day going down a checklist in order to start at the beginning of the day going down the same checklist to go do that for 50 years. Vlad, I
Mhm.
would love to go talk about maintenance on the operation side. Are you okay if we jump away from the pre-operation side and go to the operation side and talk about some of the maintenance AI style solutions that we're seeing?
Sure.
Cool. So on the left side where you guys can see the high level items, you can see we're talking about predictive maintenance. Now, I feel like we've talked about predictive maintenance for the last, I don't know, 10 years. It may even be older than the conversations that we've been having about Industry 4.0, but which dates back to 2011. But I think predictive maintenance is a really interesting solution. For those of you who followed us when we were at the Throughput conference in February, we get to have some really good, interesting conversations with the Maintain X folks talking of and those conversations I will kind of briefly summarize, and we'll let Vlad go ahead and jump in earlier on this side. But those conversations were very much along the lines of, hey, we can go and ingest the ELMs, we can go and ingest the kind of specifics of the processes, we can go and ingest the preventative maintenance items, we can go and ingest a bunch of this very quickly. But some of the next level operations comes when you're pulling in process information, so you actually know how the machines are running, and you know how long the machines are running, and you know along those lines, and you have more of that contextualized information. And I think when we talk about maintenance and operations, we'll see predictive once we can go start collecting a bunch of that, and we actually go through the process of picking the critical areas, the critical machines, and adding vibration sensors and adding other sensors so that we can go through the process of understanding how the motors, how everything else is doing fairly early on. And then I think the real value is not just Dave's site or Vlad's site. It's the can we go bring, I don't know, 50,000 of the same motors, and can we go bring 200,000 of the same VFD together so that we can go start monitoring and collecting that information and go collect that information at mass. Vlad, I'm going to pause and let you throw some of your early thoughts when it comes to predictive maintenance or maintenance in general.
Yeah, so I think, look, maintenance in general could be like a 4-hour episode, I think, on its own, because I've worked in maintenance. I was a maintenance manager at Kraft, and so I certainly have a lot of opinions as to how things can and should be improved. I think there's a lot of different angles when it comes to maintenance, right? So you've mentioned the collecting data from machines. There's a lot of questions on that side, right? I believe that number one, the currently, I want to say, generated data is being underutilized. You've mentioned you can certainly go ahead and create more data using different sensors that will, augment that pool or namespace, if you want to call it. But I also think that people are not necessarily good at processing, that information. So I'll give you an example. You could start with something as simple as, so we had a lot of belt driven machines at, let's say, PNG. And so a belt needs to be replaced at a specific frequency or based on what it looks like, right? So for better or for worse. I think the easiest, I guess, approach to this is just to have a database where you manually log, hey, this belt failed this time. So now we need to decrease the time, I guess, of servicing that specific belt for that machine from, let's say, 6 weeks to 5 weeks, right? And if no other failures occur, you're basically balancing replacing belts prematurely with incurring the downtime, right? And so, to your point, you can detect some of those failures before they happen using different sensors. Um, I would be surprised if the sensors could solve all of those issues. I think there's a lot of use cases specifically for motors, right? Because a motor, it's very evident where it starts to slip or it starts to move in a different way. You could say that motor is failing, but when it comes to those different use cases, I think it's going to be a challenge. For me, maintenance, right? That's just scratching the surface of what maintenance truly is. For me, the next big point would be, for example, creating work orders. So I've been, again, in many conversations on that side where, we're using SAP for better or for worse, and the operations team is simply unable to give us the details. They've not conducted the most basic five whys analysis, so they cannot provide us with any details, and they are unable to create a work order. So I think there's something to be said about, hey, there's some context on this specific machine. It has failed for reasons XYZ. We have tried, these five different steps. Create me a work order for the maintenance team to then look at this machine. I think that there's a huge benefit to being able to use AI on something of that nature because it can then cross reference, like you were saying, Dave, maybe other machines, maybe other, again, applications or use cases based on the information provided. I think AI is going to be really good at, again, solving some of those challenges where for a human, I simply cannot remember all the use cases. And it's what's called today, tribal knowledge. It's kind of Vlad has solved some of these failures. So based on what the operator tells him, he can say, oh, well, that's a pulley that slipped on that specific motor. That's why you're seeing these specific symptoms. But really, you should be able to query against the data and the knowledge base that has been collected over the duration or the lifetime of the machine. Does that make sense?
Absolutely. I would agree with what you're saying. And I think some of those tools will be really exciting to have. I think that it's going to be really difficult to go replace some of those things like a legitimate five whys or a process pheno or some of those other tools. Um, I'm not saying it's not possible to get to the point of we can say, this is where we're at. I'm not saying it's impossible to say this is where we're at. And for a something that is not a group of process expert humans to go give you a valid answer or a series of go check these things and come back and let us know. I'm just saying I think there's a lot of nuance when it comes to the process of going through these down these paths, and it will be interesting when it comes to that. But I 100% agree. I think writing work orders, Vlad and I have um Vlad and I have played back and forth of do we do an entire maintenance theme in which we just talk about maintenance practices and everything else and go dig very deep into there. So I think this is a good point to say, listeners, let us know if that is something that you'd be interested in, and we will do our very best to go get that on the schedule for at some point later this year. It will be interesting to see the direction that they go and the direction that we go down. Uh, let's see. So we've
Yeah.
got Doug in the comments saying that he doesn't think AI will be used for solving problems, but developing non AI code that helps with things. AI is too expensive and not necessary for 99.9% of applications. I mean, I think to that instance, I would imagine that most of us agree with you. I think, as we've talked in previous episodes, AI is very much like a catch all, right? And I think lots of these applications are being driven by quote unquote AI, but it could just be machine learning or some regression algorithms or, things that we have had access to for, I don't know, the last decade or a couple of decades. So, having said that, um, I would generally agree that we're not going to see the most powerful models that in existence being leveraged, especially because for the majority of these use cases, I would imagine that we're not using these public models. I imagine that we need some flavor of private model and some flavor of private model trained only on our knowledge, our learnings, our processes. And in that case, that would be exceptionally expensive. And I cannot imagine the vast majority of organizations having the money or resources to allocate to that.
Yeah. Let me take the next one, right? So there's a comment from Buddy also, right? So he mentioned that nearly every vibration monitoring company has its own AI for pattern recognition these days. Emerson and Bentley or GE have theirs. Check out the University of Tennessee Reliability and Maintainability Center for more information and courses on PDM technologies and AI. He said that his master thesis at UTK was around classifying bad bearings against the vibration waveforms from a paper machine, 95% classification accuracy of within a week or so of a human analyst. And I 100% agree, right? Like, so that's what I was saying in the sense of I think the use case of vibration has already been solved. I think it's taking the next step in understanding what kind of data can you actually pull from these machines where you cannot solve some of these issues with vibration monitoring because again for me, different cells are going to operate drastically different because they're going to be very unique solutions. So it's not enough to just put a few vibration sensors and be able to predict everything from A to Z as to what's happening in that machine, right? It could be a failure of picking a specific product or raw material. It could be a failure of the glue system. So I think there's a lot of solutions in the vibration monitoring space, but I don't think there's a lot of data collection for other, I want to say, maintenance or failure modes when it comes to machines. Um, let's move on along very similar lines, Dave. I would say system optimization based on historical data, right? So for me, the difference between maintenance and system optimization is maintenance is more, we're operating as everything should, and then something breaks, right? Something breaks and brings the line down. We're incurring damages on our production line, so now we need to remedy that situation via the maintenance team and solve that issue to bring it back to its operating condition. System optimization is very different, right? So system optimization means removing bottlenecks on a production line, right? So identifying and being able to say, this is where the bottleneck is. How do we eliminate that bottleneck? And how can we eliminate a bottleneck? Where, well, we can increase throughput, we can maybe increase the speed of that machine, we can figure out how to reduce the number of rejects from that machine, right? So just send more product through it. So I think there's a lot to be said about system optimization, and ultimately the goal here is to create more product or more volume per, I would say, period of time, right? So when a specific line or facility is making, I don't know, 1,000 cans per minute, we want to bring that up to 1,200. So for me, that is optimizing the system based on some of the historical data. So I think the challenges are very similar to what we discussed. Of course, you need to understand the data very well. You need to really understand where the problem or losses are in order to optimize your system. I would say that most companies are underutilizing what they currently have in place based on what I see, but I'm curious maybe to hear your thoughts on system optimization.
Absolutely. I think before we get into the artificial intelligence version of systems optimization, I think that that is a huge opportunity for so many groups. And I want to go back to a case study that we have talked about several times. So all the way back on episode 103, we had Dave Eifert of Phoenix Contact on, and he was talking how the PLC Next facility in Germany went through a process of looking at the 150,000 different tags that they had running, the different item, the different lines and different machines within that facility. They used a small subset of those, and their initial plan was for energy monitoring. I don't know if Vlad knew that's where I was going, or if Vlad was also just typing it exactly as I was saying it. But it was initially used for energy monitoring, and I believe they were able to go reduce the energy they used at the facility through the largest of machines by something like 25%, which in and of itself is a huge win, especially when you're on the sustainability course and path like our European friends are. But the other benefit was they were able to give that same historical data to a bunch of data scientists, and along with the help of some process engineers, some process people, they were able to go through the process of optimizing their facility. And I think it was double digits. I don't remember if it was 10% throughput or 20% throughput or something along those lines, but a significant amount of throughput they were able to find by leveraging that same, at this point, historical data. I think it will be very interesting if and when we get to the point of being able to blend both of those. The process now, especially the process knowledge, or maybe we can go feed that process knowledge into a model and we can come out with a solution that will go help on the optimization side and on the saving side. Again, I think historically, when you talk about having the data, when you talk about having the process experts, when you talk about paying for the data scientists to go sit down and do that, that is only the largest of large companies. So when we talk about some of that systems optimization, I imagine that we're going to go see a lot of that trickle down. And for me, I think that the most interesting parts of some of these tools and solutions are when we get out of the Fortune 100, the Fortune 10,000, when we get to the majority of manufacturers that we see, if we can go leverage those tools to go make significantly greater jumps than we're seeing at these large companies where half a percent is where half a percent is a huge bottom line value.
Yeah, I would say, look, for me, the biggest questions on the side is what kind of data do we actually need, right? Because I've been in projects on energy optimization or energy monitoring where, quite frankly, nothing was installed yet,
Mhm.
right? And so you can get, I want to say, very high level, or you can get very granular with how you collect that information. So, of course, when it comes to energy, you can just put clamps on, your three-phase cabling that's coming into a line, a machine, or an area, and you will start collecting that information. The second question is, what kind of changes are we allowed to make? I think that a lot of companies get lost in the fact that you don't realize the savings until you actually make some changes in the positive direction for I guess, for the KPI, right? And it seems almost comical to say that, but ultimately you need to be reducing the amount of energy the line utilizes in order to, I want to say, save electricity, right? In that specific instance. And I think that the question becomes with AI is, well, how do you close that loop? Because ultimately, if you tell AI, well, if the line's not producing product, just turn off the main breaker, right? It starts to create some, I want to say, patterns where it might be an issue, right? So you need to be very careful on what you're doing or what kind of a system you're using to make those automated changes. I would say that for me, before we can get there, right, before we can take that quote unquote leap, um, I would need to see a lot more information on simpler use cases. So, for example, if you have a machine that has been down for, let's say, 10 plus minutes, not producing any product, you have a sensor at the end of the conveyor belt coming out of that machine, and you see that there's no product on that conveyor belt for, let's say, 5 minutes, we can probably tell that motor to stop running, right? So that would be a very simple application where you don't necessarily need AI, but maybe if you monitor the energy utilization, you can get real small insights on what could be done in theory, so that you can then go and implement them. So I think this goes back to what we talked about on the maintenance side, is that I still feel that a human needs to be in the loop, needs to understand the data, and then needs to be able to tweak certain things in the, I want to say in this case, in the code of the PLCs or control systems, to realize the value and the gains from the monitoring side.
Absolutely. We have a comment slash question here from Raphael, who's been in the
Hmm.
comments a couple of times. Um, I don't know the answer, but we'll read it and go from there. It says, do you guys know any applications that we can simulate a virtual equipment and collect the equipment data to store in a database to then use generative AI and to learn from there? Uh, that is a good question. That is an interesting question. I don't do a lot of simulation work. I I have a couple of ideas, but as I don't know an answer, I'm going to let Vlad answer. If you have known or used any simulation style applications that would fit that bill.
I don't have any like specific answer. I can tell you that simulation in a very general sense, to a degree that is, reliable for the process, is extremely expensive. So in my opinion, you will not get the ROI you're expecting to learn from, I want to say, the data that you generate from a simulation. I think you would need to probably get together with very advanced groups on that side if you want something tangible built. I remember examples of where we spent basically as a group, right? So this was not out of my own pocket, but as the company, a couple of hundred thousands of dollars to simulate a fairly basic process on the mechanical side, and very little value was gained out of that. So I think I don't have a specific suggestion, but I would be very careful how close that simulation is to what you're looking for, and then how valuable the data you collect from it is going to help you solve like any problems.
Yeah, as I read it, I almost wonder if he's asking if he knows of anything that can simulate a theoretical application so that he can then feed into a generative AI solution and allow it to learn from there. So I
Hmm.
do not know. I don't do a lot of simulation solutions. I will say we've had several conversations with Cole and Gavin on like the process simulate side and a whole slew of applications that they have over in the Siemens group. And so
Hmm.
I know that that is a thing. And we've had a couple of conversations. We'll try to link Colm. We've had a couple of one conversation I think online with Max Fitzpatrick. And then I know we've also had a couple of other simulation conversations as well. For me, it's interesting as we get deeper and deeper into the solutions and applications, the reduction in cost and the additional applications that we can use and find value with. Again, to Vlad's point, I have not. I guess I just haven't had enough specific applications that I have used. But I also don't do a lot of automotive work. And I think historically, up until the last couple of years, the majority of what you see is on the automotive side. Definitely some case studies and values on the machine builder side. Having said that, if you guys have a piece of software that would be valuable for Raphael, please go ahead and drop it in the comments or send us a message, and we will go ahead and update everyone if we find an actual solution to that. Oh, Raphael has actually gone and updated. He says the simulation is to use to test as to collect the I think the data before application on site, as simulate pumps, valve actuations, etc. So we can use the simulation to show the customer is about predictive maintenance and importance with artificial intelligence. I will say, and I'll go dig up the case study. We had a conversation. I don't remember who it was with, but someone was using one of those Siemens tools in as a machine builder in order to simulate as a phase one or as a phase two what the line was going to look like, and it reduced their lead time from like 18 months of back and forth with drawings down to, I think it was less than 6 months, but it's probably been a year or more since I have looked at that. I will go dig for the case study. I'll go drop it to
Hmm.
you, Raphael. And then beyond that, we'll go drop it in the comments and show notes of this episode if you guys are interested. Not a problem. Trying to send messages on LinkedIn on your phone is terrible as a whole, but we appreciate you listening and asking questions. Vlad,
Yep.
we are somehow, to the surprise of no one who is a longtime listener, um, barely started this whiteboarding exercise that we have, and we are nearly up on time. Can we pick one more application or one more area that we want to go discuss for today, please?
Well, let's. There was a question I think we glanced over,
Okay.
which was important to address. I'm gonna pull it up right now. So it says, for some reason, it's not pulling up the actual LinkedIn user. Maybe you can help me with that. But ultimately, it says, if you're optimizing systems, why would you have AI optimize systems when at best it is going to use existing known methods for optimization? So a couple of things, right? So number one, I I would say that at least I'm not suggesting that AI is going to be doing all of this as if it's a wave of a magic wand, right? So I think that the specifics are extremely important, and I think there's a conversation to be had around what exactly are we able to do, and what exactly are unable to do, right? So when I talk about system optimization, even I think there's dozens, if not hundreds of examples where I could see AI being completely useless, and then maybe some specifics where it can be used. I'll give you an example. So a lot of factories are deploying OE as a first metric, right? So think about a small to medium sized manufacturing, even in large ones, right? So a lot of the large facilities are still unable to pull up OE if you ask them on the plant floor, right? So a lot of them do that very manually, and quite frankly, again, based on my vertical and my experience, they would have, let's say, OE measured by the entire line, so you could see how many cases of product we've been able to produce. Well, for me, that information, to some extent, of course, for someone in purchasing and maybe on the operation side, that is interesting. But for me, what's more interesting is trying to figure that out by asset and then trying to optimize for, like I mentioned, the bottleneck. So if I can automatically, right, when I say automatically, is I think if I can get the aggregate of that data, which in most cases I'm unable to get, if I can analyze that data using questions from AI, right? If I can say, I have this specific, for example, filler, I have this specific machine, I have this specific, type of an application. What are some of the suggested optimizations you can give me based on the data I'm feeding you? And like I said, I'm well aware that probably a lot of that data does not exist. Probably a lot of that information is not being shared outside of a specific manufacturer, but I think it would be interesting to pilot a system of that nature, right? But again, I'm not suggesting that AI can optimize any process for any specific reason. I think it's just important to talk through some of these examples and maybe understand where it might fit and where there is a tangible problem and a lot of human, I want to say, capital spent just sitting there, and a lot of that tribal knowledge, so to speak, being utilized versus something that we could be pulling data for. Does that, hopefully that answers the question that was
Yeah,
asked?
I think that was a good comments. It was Doug. Apologies to Doug. We're having a bit of a lag on about half of the comments coming in, but no, I would agree with Vlad. I think my initial comment was in relation to that Phoenix Contact case study and our conversation with Dave Eifert. And they didn't use any tools other than some probably very expensive data scientists and some probably slightly expensive process experts in order to go through the process of figuring that out. And I
Hmm.
certainly think that they are the outlier of people who would have all of that information. I think, generally speaking, you might have enough data and information in order to start to get a little bit closer. I think the vast majority of at least initial process optimizations are going to be go down the path of we're going to go do it manually. I have seen one or two solutions that I can't talk publicly about, but when they were trying to use AI or really machine learning in that instance, like their goal was we are currently running at like 95, 96, 97% uptime. The next quarter of a percent or the next half a percent is millions or tens or hundreds of millions of dollars valuable to us, so that's where we're using some of those tools in order to go wring out the last quarter of a percent or the last half a percent. And everything else is just unexpected downtime, or someone has flubbed and we have run out of this particular raw material. And so we're down for 92 seconds, and this 92 seconds destroys our entire quarter sort of solution. So I think for some of those, we will see some of those tools. I think for the vast majority of people, they are so many, process data collections, so many everything else away from being able to feed a model that doesn't exist all of their information so that the model can go tell them what they're doing incorrectly.
Yeah, and I would say, look, I guess like to close off on that comment, I think again, system optimization can mean different things to different people in different groups. So
Mhm.
it's important also to recognize it could be just starting points for some of those professionals who are extremely expensive, and maybe it is just saving a couple of hours for them to understand the system better, right? So again, it is not necessarily in the context of, hey, let's just throw AI at this problem and it will automatically optimize the system. The conversation here is about different stages of how a system needs to be optimized and where this could come in and help in a general sense. To your question, Dave, let's maybe pick another area for the final comments, right? And so for me, that is quality slash inspection slash reject optimization, right? And I think I've told this story maybe on the podcast, but at least in some of our conversations, I have certainly spent many hours, days, weeks, if not months, writing software
Hmm.
for different cognitive systems, right? And of course, a vision system is a vision system, whether that's Keyence or Data Logic or a few other brands of vision systems. But ultimately, I would say for me, it was always the balance of, and that's the balance of any vision system really is, you don't want to reject something that is good, right? And you also
Hmm.
do not want to reject something that is bad, right? You don't want to send something through that is bad. And
Yep.
that's the basis of the concept of false positive and what is it, false negatives, right? Basically, that's what you're balancing on. So the effort that you put into your system will basically be based on those percentages, right? And so depending on the organization, again, you can rework some of that product. What I mean by that is, let's say you have a label missing of a jar, the jar gets rejected, the jar just gets puts back on the conveyor system, and it gets another label applied to it. There's not a whole lot of loss. In a lot of different instances, the product is basically scrap, right? So if something happened to that product where it cannot be recovered, it needs to be recycled, the material needs to be pulled out, and so it becomes a lot more difficult to, or I guess it becomes easier to justify a system that is better to not reject good parts and to not pass through bad parts. So ultimately, I think that AI, and so this is going to be again the nuance. This is not, we're not talking about LLMs here. We're talking about image processing type of AI here. It
Hmm.
truly shines where it's able to look at a lot of good parts and it's able to identify sort of the bad parts. But I will be
Hmm.
honest with you, at least I have, so I worked on fairly high speed applications where, the name of the game was we had 30 milliseconds to say if the product is good or bad. um, so I've not been able to test if something of that nature is possible with the current AI tools, but I would
Hmm.
assume once you trained on enough samples, it should be able to work. Right now, whether that's reality or not, I could not confirm. But based on what I'm hearing, it is certainly changing a lot of the ways machine vision is implemented in manufacturing.
Absolutely. I would say machine vision maybe should have been the one that we started with, Vlad, because I think that is the most straightforward application that we can see. When you and I were at Automate a couple of weeks ago, we got to see a bunch of explicitly UR robots that were using some flavor of camera and AI. Last year at Automate, we talked to Jim Wilmont about robot pick AI, which was very new. And I'd seen a bunch of those applications. And it's basically, hey, we have a bin of dissimilar things. Go pick it, figure out what it is, and put it in. Well, in that instance, it was the same bin, but in theory, a different bin. And their early theories were this could be for bill of materials. This could be for like a distribution center of a bunch of stuff is just dumped in the same in the same bin, and we need to go pick it out, which was interesting. And then this year we had a continuation of those conversations, and it's a bit superpowered when it comes to the vision sensor or the vision system and the robotic arm, which I thought was really cool. And then another one, another application outside of the physical robotics is inspection cameras, as you mentioned. I've seen a bunch of Teledyne examples. I've seen some Cognex examples. There was a new example right next to the robot pick AI, which was called Inspecto, that Vlad and I got to go see when we went to one of the offsites earlier in the week at Automate. That was really cool, where you basically feed it 20 good pictures and it can confirm it's got, X number of pieces where they're supposed to be, and it can confirm that there's nothing else there, which I thought was really cool. And it takes away a lot of that program and a lot of the artistry that Vlad and I have talked about that I don't possess the ability or perhaps the patience to go do. But you can go get up and running very quick. And I thought that is interesting, in going and leveraging some more of that compute power
Yeah.
through IPCs, through some of these other tools. So I 100% agree and understand what you're saying. I think that's a really interesting application. I've had some conversations with clients about that, and I legitimately expect a lot of those applications to continue their entry into the field because of low barrier of entry, low costs, etc., etc. Vlad, we're running up on an hour. But I just realized I think we've got a bunch of people in Manufacturing Hub watching us live who maybe don't know us. And we did the thing where we just don't really introduce ourselves or the show. Do you want to tell the people about Manufacturing Hub and why they should come back and watch us again next week? Or do you want me to tell the
Well,
people about it?
I just had an idea based on your comment of the vision systems. Let me throw that idea up there because I'm probably gonna
Okay.
forget,
For
and
all
then
of
I'll
our
let
new
you make the
listeners,
introduction.
100% par for the course.
Yes.
Vlad and I just get into it, and we get into it.
Yes.
So
So I think,
okay,
yeah, you know what would be interesting, right? So for me, ultimately, again, when you work with vision systems, based on the settings that you put in, right, on or based on what your model learns, and let's take a simple application like a barcode scanner, right? So you print the barcode, and then at the end of the line, you need to validate that the barcode has been printed correctly, right? Imagine a case where that barcode gets either, like smudged or whatever, but your vision system still says like it's good enough, right? There's obviously a gray area where it's perfect, where it's bad, and where it's kind of good enough. So I think what would be interesting, going back to this question of AI, is tying in the comments from the end user of that, let's say product, back to the vision system, right? So let me give you another example, right? Because I worked a lot in femcare and CPG type of products, and you would get a complaint based on the product quality, not necessarily the packaging, but the product is causing discomfort, for example, right? And so if you could tie that back as a verbal comment to the vision system and say, hey, you need to adjust the parameters to tighten up some of those rejects, I think that becomes extremely interesting as a use case, especially for, I would say, for smaller companies, right? Because that's ultimately where they can find those that leverage with their customers. So I think it's something definitely to think about as we I guess progress through the world of AI. But let's go into that introduction. I'll let you make the pitch.
absolutely. Everyone, if you guys are new to Manufacturing Hub, welcome. Vlad and I specifically didn't put up our names so that you didn't have our names on the whiteboard, and that perhaps was a mistake. My name's Dave Griffith. The guy sitting to the right of me on your screen is Vlad Romanoff. We've been running Manufacturing Hub for the last nearly 5 years at this point. This is episode 212. Every week, or just about every week, Wednesday at 4 o'clock East Coast time, 1 o'clock Pacific time zone, 10 o'clock Central European time most of the year. We get on as practitioners in this space, guys who do the work, and we go have conversations either amongst ourselves or almost exclusively. We go have a guest on or a couple of guests on, and we just have really nerdy conversations about all things in manufacturing. Most months we pick a theme. This month, we've picked two themes. We're talking about AI in manufacturing this week, and with our guest Billy next week. And then we're going to go jump into robotics for, I believe, the second half of June. And then we're going to go talk about a bunch of other things as we get into July and further on. You guys, if you want to go find us live, you can go find us live at several of the major trade shows and events during the year. But most of the time, we just like to go have fun conversations as practitioners in this space, two practitioners in this space, and it should be a fun, educational 75 ish minutes of your Wednesday afternoon. Come find us here on LinkedIn. Come listen to us on YouTube. Go find us just about anywhere that podcasts are from, and basically everywhere in between. For us, our thoughts is always that this has been a community show. We enjoy it. If it's not a good, fun 90 minutes of our Wednesday afternoons, we will probably stop doing it. But at this point, I don't think that we have any plans to pause or stop doing it. Having said that, thank you guys so much for coming to. Uh, Thank you so much for coming to hang out with us on Wednesday. We'll be back same time, same place, 4 o'clock Wednesday East Coast time. next week. Again, this has been episode 212. Go listen to several hundred hours of us continue to go talk about these applications. If you guys have made it this far, make sure you're following Manufacturing Hub Network over this way on the screen. I can't get my hand in on LinkedIn. Make sure you're following us on YouTube and listening to us on podcast form. Feel free to go ahead and follow along with Vlad and myself. And now we've got our names back, but please feel free to go follow along with Vlad and ourselves, especially on LinkedIn, which is where you're going to find most of us and most of our content. Until next week, we'll see everyone soon. Thank you.